Well, hello there. This is another look inside a GSSL bus compressor with some more interesting modification and bolt-on little boards from Expat Audio. On this particular version we have two boards which I'd like to introduce you to. You probably already know the turbo board, which is the board which allows the compressor to act like a proper SSL compressor instead of the GSSL only performance. And in this case we can see that it's also switchable between turbo mode and standard mode. But also on this version we have the another little retrofit board which should improve the performance for a lot of people. Certainly if you've been having any trouble with hum and noise on your GSSL compressor, this is the CRC board, and it's basically a dual rail filter stage which rectifies and sequentially filters the incoming signal on the way to the board. The retrofit is extraordinarily simple. It's 11 components basically on a board, and all you do is you just cut the secondary wires coming from the secondary of the transformer on their journey to the board and insert this board, and your hum problems will be gone. I guarantee it. If you have any 120 Hz ripple, this solves the problem. The GSSL board layout, unfortunately, with the onboard rectification and smoothing, is unfortunately excessively prone to picking up ripple noise, and that's due in no small part to the flow of current around the board, basically. So this is one board. It's very simple to do. You just install the components and cut the secondary wire. You can leave, in this case I've chosen to remove the second bridge rectifier, which would be right by the by where the power connector comes in for an off-board power supply. But you can leave the bridge rectifier in there. There's absolutely no harm in doing that as well. Also, with this modification, the regulators on the board run significantly cooler as well, and that's another plus. Second board, which I'd like to show you a little bit about, is this particular board right here. This is a VU meter driver board. And a number of people have asked how to make the GSSL metering behave a little differently. This is the standard meter here, which, as you can see, as you increase the threshold to make the compressor more sensitive, you can see the gain reduction shows a right deflection of a meter. The number of people have asked for something rather like an 1176 or an LA2A display, where basically you have a needle which points at 0, and then with progressive gain reduction goes down from 0. Now there are a few ways of doing this, but only really one proper way, because we're going from a logarithmic control voltage to a linear display. So what we need to do is demonstrate how easy it is to put this in. The board itself is manageably sized, and in terms of retrofit, there's no track cutting on the board. Basically we have one set of 4 wires here, which goes off to the main board, and it solders on extraordinarily easily. The 4 connections which you make onto the main board are right here. You don't even need to remove the board. There's a negative 15 volts connection right here, positive 15 volts connection right here. Right next to the regulators is a 0 volts connection. These are all just soldered onto links on top of the board, so you don't even need to remove the board to do it. The 4th wire is right down here, and it solders onto a resistor end or jumper, depending on whether or not you have a resistor or a jumper fitted right here next to the connector. It really is very simple. Once the board is built, it can be installed in literally 2 minutes. That's all there is to it. Those are the 4 wires coming in, and then we have a pair of wires here which go off to the VU meter. And the VU meter is basically an absolutely standard VU meter. Here we've got it showing on a SciFan, and you'll need to add the appropriate series resistor. In this case it's a 3.9K resistor, because that's the resistance that the SciFan requires. There is only one preset adjustment on the control, and it's this trim pot right here, and the adjustment for that is to set the rest position of the needle. It has a range where it'll go basically from the end of the scale basically down to 0. All you need to do for that is adjust that so that it points squarely to 0, and that's the only adjustment that's required for the VU driver board. How accurate is it? Well, let's see. If we want to know what the correspondence is like between the readings on the VU meter for gain reduction and the actual signal coming out of the unit, this is what we'll do. We have a tone being sent from the nitric here, 1 kilohertz. And what happens is, if I adjust the threshold control and turn it down, you can see that the unit starts to go into compression. We can read the signal level coming out of the unit on the nitric here, which we've set to a local 0 dB reference. And here on the VU meter, we've got the gain reduction indication as displayed from the XPAD Audio VU driver card. So now, if I bring the threshold down till we start to see the onset of gain reduction, we can see that at 0 dB on the VU meter, we have 0 dB gain reduction, 0 dB output level. If we turn it down so that we get minus 1 dB of output level, let's turn that down right now, it's close enough, 1.0 something, then the VU meter also shows minus 1 dB of gain reduction. If we turn it down to 3 dB of gain reduction, for example, we can see that the VU meter indeed shows minus 3 dB. 2 dB of gain reduction shows almost exactly 2 dB on the meter. You can see basically it's accurate to significantly within a tenth of a dB. So there's basically minus 2 dB, and that's minus 2 dB on the meter there. If we take the needle down to minus 4 dB of gain reduction, we can see that it's basically minus 4 dB on the meter there. And this is entirely down to the width of the needle, basically. If we take this down to minus 5 dB of gain reduction there, you can see minus 5 dB almost exactly on there, and so on and so forth. Basically minus 6 dB there, there's minus 6 dB there. They agree almost entirely, basically. Again, minus 7 dB of gain reduction on here is going to be minus 7 dB on the meter over there. Minus 10 dB here, minus 10 dB right there. The two of them agree basically absolutely. Now, one other advantage about using a standard passive VU meter like this, and again, we'll show you minus 20 dB of gain reduction there, although we're well out of the accurate resolution of the meter there, but it's basically still showing minus 20. So if we let this go back to 0, we'll see minus 0 dB there and 0 dB here. The two of them agree absolutely. Okay, here's another little demonstration I have here. This is a pair of SciFan VU meters. Again, they're both passive VU meters, but the second VU meter is basically wired here straight across the output, so it's just reading the signal going back into the nitric coming out of the unit. As I turn down the gain reduction by reducing the threshold, you can see that the two of them read absolutely the same. So the one on the left is reading the output level, the one on the right is reading the gain reduction indication. And basically by turning down the threshold, we can see that it affects the signal. The difference is if I now mute the signal, you can see that the left one is actually showing the output level signal and the right hand one is showing the gain reduction. If you want to put 2 meters on your unit, you're perfectly able to do this kind of thing. Now if I show the gain reduction here, as I mute the signal, you can see that that the unit goes up here like this. Now, the makeup gain on the output of the unit, so the one on the right is affected by the makeup gain, but because the gain reduction of the compression is not affected, then you can see that the needle on the right still shows a constant amount of gain reduction, while the one on the left shows the actual output signal. So we reduce the level of the signal with compression and make up the actual signal level, which is the meter on the left, with makeup gain. Now as I turn up the threshold, you can see as the gain reduction goes down, the makeup gain takes the left-hand needle off the end. You don't have to use two meters for this. Just by using some simple passive switching to switch between the output of the VU driver board and basically a parallel tap which is coming across the output line from one of the two channels on the output of the device, you can switch between output and gain reduction. If you want to put a 3-position switch on it, you can switch between output left, output right, and gain reduction. If you want to put a 5-position switch on it, you can switch between input left, input right, gain reduction, output left, and output right. Or if you want to put a 3-position switch on it, you can switch between summed input left and right, or gain reduction, or summed output left and right, by just doing a couple of clever wiring tricks across the differential outputs and inputs. There you go. There you have it. The Expat Audio VU meter driver. Details at expataudio.com.